Hello everyone, I am Ananya MR. I am student studying Electronics and Communication Engineering at Saptagiri College of Engineering. I am here with this video to present you all about my embedded system internship, and the project done during this internship was a washing machine simulation. This internship was offered by Emertxe Information Technologies. So I would like to thank Emertxe for giving me this opportunity to explore embedded system. So let's get started with this video. The key learnings of this embedded system internship are: initially, we the interns were given the overview of embedded C programming, then the overview of embedded systems. Later, we studied the architecture of PIC 16F877A microcontroller, using which we have done the project. Then interfacing of the peripherals like LED, CLCD, digital keypad, timers, fan and buzzer also was taught during the internship. So the initial days of the internship, there were embedded C classes. I would like to share what was covered during those classes. First, we studied what is embedded C and why is it used to design embedded systems. So, embedded C is a powerful extension of the standard C programming language, specifically tailored for developing software for embedded systems. So, why C? Because it's a general purpose language, it's a free formatted language, and it also allows direct access to hardware components like either memory addresses or even input output ports and peripherals. So, low level access is very much important. Then embedded C is known for its efficiency and speed, making it suitable for the real-time applications which are built. Then we studied about keywords. So the keywords are the reserved words that have predefined meaning. Basically, there are 32 keywords in C. Say for example, int, for, break, double, go to, and many more. Then the data types. The data types are used to declare what type of data is being stored in a variable. So it also determines the size of the memory allocated to a variable. Major data types used are character, integer, float, and double. So that is being shown in this figure. Then these data types or the variables declared under these data types can be modified with respect to their properties using the modifiers. So, using modifiers, we can increase the size allotted for a variable. Say, normally for a character, 1 byte of memory is allotted. So, by using long, short, signed, unsigned, we can increase the memory allotted for that. So, next we studied about the conditional controlling statements. So, in the normal, the flow of execution is sequential. But in order to change the flow of execution, we use some conditional statements or branching statements and loop statements. So, in branching statements, we have conditional as well as unconditional statements. As we can see, there are conditional statements like if else, nested if else, and switch. All these statements check for a condition, and if the condition is satisfied, then the block of code under that condition will get executed. Else, the other block of code which is following that statements will be executed. Then coming to the unconditional statements, there is go to, which is used to move to a some specified location that is being labeled without checking for any condition. And then break and continue are used to come out of a loop without waiting for any condition or checking for any condition. Then return statement, that is used to return some value from a function. So every function should return some value. Then we studied about the loops, that is the for loop, while loop, and also do while loop. So these loops are used for repeated execution of a block of code. Then we studied about operators in C. There are different operators. These operators are used to inform the compiler to perform some specific operation. So there are different type of operators like unary operators. Under unary operators, we have increment and decrement. Then arithmetic operators, we can perform addition, subtraction, multiplication, division, and modulus. Then we also have relational operators, that is less than, equal to, that is doing some comparison operation between two different variables or data. Then logical operators like logical and, logical or, and then logical not. Then we also have bitwise operations, which also includes left shift, right shift, and then and, or, XOR. And then we also studied about assignment operators. We can either directly assign some value to the variable or even update and then assign. All those things are there. Then ternary operator is a conditional operator. So some condition is being specified. If that condition is true, then the statement after the question mark gets executed. Or if that statement is false or the condition is false, then the statement after the colon gets executed. Then moving on, we studied about arrays. So array is a collection of data of same data type. So the addresses allotted for storing these arrays, it is sequential. And indexing of the array starts from 0 and it ends with the size of the array minus 1. Say if an array contains some 6 values, then the addressing of it starts from 0, 1, 2, 3, 4, and 5. Then we studied about pointers. So C also supports pointers. This is one of its advantage for being used in embedded system development. So pointers are the variables that store memory addresses of other variables. Instead of holding a direct value, a pointer holds the location in memory where a value is stored. It is used to return more than one value from a function. So we can just return one particular value from a function using the return statement. If we have to return multiple, then that can be stored in some memory locations and that address can be shared or returned using a pointer. Later, we studied about the byte ordering ways in the memory. There are two types, that is little endian and big endian. In little endian method, the least significant byte is stored in the lower address and most significant byte is stored in the higher address. Whereas in big endian method, the most significant byte is stored in the lower address and least significant byte is stored in the higher address. Then we studied about functions used in C, that is declared. It's a self contained block of code designed to perform a specific task. Defining or declaring a function does not mean just writing one function, it also includes function mentioning the function prototype, then the function definition, and that function should be called in the main program or wherever it is required. It can be called any number of times by passing different parameters based on our requirements. So here we can see how a function is being declared or defined in C. Firstly, we have to mention the return type of the function and then the function name, then the parameters being passed to this function along with the data type. Then inside the curly braces, we are mentioning the block of code that has to be implemented inside this function. Then the last statement should always be a return statement, that is returning some value to the point where it was called. Then we studied about strings. So string is a sequence of characters terminated by a null character. It's also called as a character array. Here we can see different types of declaring a string or defining a string. So character is the data type, then str is the name, and this defines within the square braces is the size of the string, and it is defined inside a curly braces like this. Or it can be written just like this without defining the size, and it can be written inside inverted commas. So from the second week of the embedded system internship, we were being taught about the embedded systems. So any system that's a combination of hardware and software which is intended to do a specific task can be defined as an embedded system. So there are different categories of embedded system, and we studied them as follows: the standalone, real time, the networked, and the mobile. There are two types of standalone embedded system, that is the slaves standard sorry slave standalone embedded system, which blindly follows the instruction given by the user, and the other type is independent slave standalone embedded system, which can take decision by its own without human interference, that is it has some intelligence part in it. Then we studied about real time embedded systems. Real time embedded systems are time bound systems. There are three types: hard real time embedded system, where meeting a deadline missing a deadline can lead to some life loss. Firm real time embedded system, where missing a deadline will lead to some property loss. And soft real time embedded system, where missing a deadline can be tolerated. Then we studied about the networked embedded system, where multiple components and devices are connected together to perform specific tasks. Then we also studied about mobile embedded systems. So these are the embedded systems which are portable or movable. Then we studied about the components of an embedded system. So in this block diagram, we can see here being mentioned as sensors. So sensors act as the input to the embedded system. And then that is given to the core of the embedded system, that is a microcontroller or a microprocessor or even a system on chip. But this is being interfaced through an ADC. That is because the sensor output is most of the time or always analog. So that has to be converted to digital in order to interface it with the microcontroller or processor or SoC. Then the output of this is given to actuators based on the input. Again, that is interfaced through DAC, digital to analog converters. Then there is a memory which will contain the software program embedded, and also whatever operations are being conducted, those data are also being stored in the memory. There can also be an FPGA or ASIC, and the diagnostic part can include some hardware debugging tools or even software debugging tools. Then human interfaces based on the application. So this is a block diagram representing the components of embedded system. So we studied more about even memory. So the types of memory, that is volatile memory and non-volatile memory. Volatile memory, that is only available till the power exists, whereas non-volatile memory, it will be available even if there is no power. So RAM is a volatile memory. It's also called the data memory. N number of read and writes can be performed on RAM. So there are two types of RAM, that is SRAM and DRAM. SRAM is static RAM, which is faster and consume less power, whereas DRAM is quite slow, but it consumes also more power. So example for SRAM is catch RAM, catch memory, and for DRAM it's main memory. Then coming on to non-volatile memory, it's ROM, read-only memory. The word itself says it can only be read n number of times, but written only once. or it can be reprogrammed based on the type of ROM we are using. So it can be a PROM, which is programmable ROM, and then EPROM, erasable programmable ROM. PROM is PROM is programmable only once, whereas EPROM is erasable and programmable, but it takes time for erasing. Then EEPROM is electrically erasable PROMs, while again the storage part is very small in EEPROM. Then we can also use flash memory, which combines the erasable property of EEPROM and the storage property of the main ROM, standard ROM. So then we studied about the differences between the microcontrollers and microprocessors. Microcontrollers are less flexible while microprocessors are more flexible, but microcontrollers are easy to design and program for specific tasks using a single IC. But microprocessors, they're complex to design and they're used for general purpose systems. So for specific applications, we generally select these microcontrollers. Example of a microcontroller is 8051, and for microprocessor it's 8085 microprocessor, and even Intel microprocessors are available. We also studied the difference between the von Neumann and Harvard architecture. That is, von Neumann architecture uses a shared signal for code and data receiving and passing on back to memory. So accessing. It is less complex architecture, whereas Harvard, it uses physically separate signals for accessing the code and data memory. Then we studied about system on chip, which consists of microcontroller, microprocessor, and also some peripherals on a single chip. That is why it's called a system on chip, making it ideal for complex structured designs. Then coming on to the heart of our project, that is the PIC16F877A microcontroller. It's a microcontroller with 40 pins. It follows Harvard architecture and there are 5 bidirectional IO ports. It's an 8-bit microcontroller. So as seen in this figure, it shows all the 5 ports that are present in the microcontroller. And every port has a tri-state data direction register. This data direction register is used to configure a port pin or the entire port as input or output. So if tris register is set to 1, then that whole port is configured as input. If it is set to 0, then that whole port is set as output. We have also studied some program to turn on LEDs and all while doing the internship. Then we have studied about different peripherals, their architecture and programming of those peripherals for any applications that is required, and some small programs related to the operation of those peripherals. But I would like to elaborate on every peripherals when I go into the project. So let's begin with the project. So the project is the washing machine simulation, as I said before. The purpose is this project focuses on simulating a washing machine using the Pixim lab. Here we are using Pixim lab, aiming at the replication of the real world washing machine. Maybe not completely, but up to some extent we have done it using the virtual environment that is available. So the project begins with some understanding of how a washing machine runs and its cycles, everything. Then the tools used in building this project is, the first one is the MPLAB X IDE. So this is an integrated development environment. This software or tool is being used by us to program every peripheral and also the microcontroller that is being used using embedded C. So it was nice to learn using a new tool. All these 3 tools were very new to me, and I'm happy that I have learned some new tools. And then MPLAB XE8 compiler, it's a cross compiler used to convert the source code we have written in high level language to the hex file that is understandable by the microcontroller or the hardware. And then PixSim Lab Simulator is a simulating tool where we are finding multiple boards consisting of multiple processors or even the controllers and peripherals. But we have chosen PIC16F877E microcontroller and the peripherals which are available in that. So the peripherals used are digital keypad. So now I would like to elaborate on each peripheral being used, but I have not included much slides, but I shall explain it. Firstly, the digital keypad. We studied about the digital keypad during the internship. The digital keypads are based on tactile switches. So there are 6 switches available on PIC microcontroller, and all these are pull-up interfaced. Generally, they can be interfaced using pull-up or pull-down network, but here in PIC microcontroller, it is pull-up interfaced. And we know there can be some bouncing effect as these are mechanical switches, but still that has to be overcome when we are programming it. And then we have studied about the CLCD. CLCD is the display which is we have used during our project. That is nothing but a character liquid crystal display. That is a type of LCD. So it has 16 interfacing lines, and this has 16 cross 4 display. That is 16 characters per line and 4 lines as such can be used. So we can display all the ASCII characters using this display. So there are 16 pins in that CLCD IC. There are various pins for, and it is 8-bit. We can transfer 8-bit either right to that CLCD, that is an output peripheral. So the data given to that CLCD can either be the data to be displayed or even sometimes the instruction, but that can again be configured using the register select pin. So if that is set to 0, then it's for instructions, and if it is set to 1, then that is for data. Then there is a pin using which we can even control the contrast, and there are pins which can be configured saying that we are writing to that or we are reading from the pin D7, that is the data pin. And then we also have studied about timers. So the timers are basically used for either counting any task or the time, and it's a default peripheral in every microcontrollers. It is used to create the delay between the tasks, and it also schedules some task at the particular time by measuring time. So whenever a timer overflows, then an interrupt is raised. We studied about certain keywords which are related to timers, like the resolution, which is the width of the timer register, and then the tick, it is the change of the timer register from one value when it changes from one value to other, and then quantum, it's the tick duration for one tick. And there are 3 timers supported by the PIC microcontroller. We are using timer 2 because it is easy to program. So it also supports pre and post scaling, and it is an 8-bit resolution timer. And again, there are multiple bits that can be configured, that has to be configured in order to interface these timers or to program these timers. Say we have to enable the GIE and PEIE. These are the interrupt enable bits. That is, one is the global interrupt enable bit and the other is the peripheral interrupt enable bit. So these has to be enabled to use timers in interrupt mode. And then there are certain registers like PR register and TCON, TMR. All these has to be configured for the functioning based on our requirements. And then buzzer, we have used it for indicating some operation completion or to indicate to do some operation by the user in such way. And even the fan, these are interfaced to the microcontroller using port C pins. The pin 1 and pin 2 of port C are used for interfacing the buzzer and fan respectively. So moving on, the requirements of the project. So the main part is the microcontroller, and we have to display various screens based on the operation that is being performed, and we have to take the interface from the user. So that is done using the CLCD and the switches. So there will be a power on screen, then we have to press switch 5 which will turn on the washing machine, and then there is a pause and stop which is done by switch 6 between the operation of the washing machine. Then there is a navigation used done by using switch 4, that is to move from one option to other in a screen. And then door status is also being checked, that is the implementing when the door is open, it has informed that door should be closed and the operation should be stopped when the door is open. So that is being implemented. And the buzzer to indicate the completion of the operation, and also to indicate when the door is open, it has to be closed. At that time also we have used the buzzer. And then motor, we have not interfaced any motor, but it is the fan we have used as the motor to indicate the operation of the washing machine. So these are the required screens. First screen is this which has to be displayed, that is press key 5 to power on washing machine. So this will be displayed once we press the switch, that is the key 5, then it will move on to this screen. That is, this will first and the fourth line will be coming in rolling, and then the power on, that is coming sequentially. And then after a delay of certain time, then we have to get the screen which displays all the washing program options. That is, we have included some 11 to 13 washing programs, that is daily, heavy, delicate, eco cottons, whites, and then rinse only, rinse plus dry, some spin only, all those things. And then we can move from one option to other by pressing switch 4. Short press of switch 4 will move from one option to the other. So the star indicate which option it is pointing to. So then a long press for any option will take us to the next screen, that is the water level screen. In this we can select either auto, low, medium, maximum, and then minimum. All these options are there. Again here, moving from one option to other can be done using switch 4 short press. A long press of switch 4 will take us to the next screen. So this screen will be displayed where it tells press switch 5 to start or switch 6 to stop. If switch 5 is pressed, then it will move on to the next screen. If switch 6 is pressed, then it will come back to washing program screen. So this is what is happening. And here it displays what is the function that is being happening. It is washing or rinsing, or is it spinning, that is being mentioned here. And the time will also be displayed, that is it will go in a decremental order. What is the remaining time will be displayed here. And then switch 6 can be pressed to pause the operation, and to start back we have to press switch 5. And if the door is open, then it will mention the door is open, please close it. And once the program, again if we close the door, it will get started. And once the program is over, it will show that the program is completed, remove the clothes. These are the requirements. Based on these requirements, now we shall see the project demo that I have done during this internship. So washing machine simulation project demo, I would like to show the project demo of whatever I have done. So this is the PiximLab tool. To begin with, this is the first screen, the power on screen. It shows press key 5 to power on. Here this is key 1, key 2, key 3, 4, 5 and 6. So I am pressing key 5. It's turning on, the screen is changing, powering on washing machine. And now we are seeing all the washing programs. So pressing switch 4 will change the program: heavy, delicate, whites, stain wash, eco cottons, woolens, bed sheets, rinse plus dry, then dry only, wash only, aqua store, and then back to daily. So all these programs are there. So to select this program, I have to long press switch 4. Then that will change to water level screen. So here in water level screen, again we can move from one to other by pressing switch 4 auto, then low, medium, high, max, and again auto. So to select auto, I will long press it. There was a bug, sorry for that. So long press will take you to the next screen. Here it says switch 5 to start and switch 6 to stop. If I press switch 5, that is this, then it will start. See, it has started. Here it is displaying the function that it is washing, and time 36, 35, it is decrementing. So if I press switch 6, it will pause. This is switch 6, so I'm pressing. So the operation has stopped. Now the fan is not rotating. Again, to start, if I press switch 5, it has to start. Yeah, it has started. It's again rotating, and the timer is decrementing from where it had stopped. The function has changed to rinse. And opening the door is being implemented using the switch key 1. So if I press this, it means that the door is open. So if the door is open, then it will show as door is open, close the door. So if I pause this buzzer sound, then it will be better seen. Door is open, close the door. So once I leave this, again it starts. So once the operation is completed, remove close, and it has come back to washing program screen. And one more thing we had not seen, that is coming back to the screen, that is stop. So if I select this one, and then anything. So here if I press switch 6, it should stop. Again go back to first, see, washing machine screen. So this was the demo. Finally, the washing machine simulation using PiximLab served as an effective tool for learning and applying the concepts in embedded system. So it offered a hands-on experience that complemented the theoretical knowledge and also provided a foundation for the further exploration in this field. So I would like to extend my gratitude for Emerging Information Technologies for giving me this opportunity. I extend my gratitude to Anusha ma'am and Guhapriya ma'am. Thank you.